well. Let me go ahead and share my screen. Yeah, as Custom mentioned, we'll go through a couple of scenarios that we have that we prepared for the demo. So I'll walk you through some of the things you're probably already familiar with, which is the like Mongo UI there, as well as some more like type of things there. So if you can see my screen now, perfect. So we're going to be working with fundamentally two sets of data here. So this race prediction data that we have there, and then this orders data. Now we're going to have the order data to work on a ticket that has been created for us in Jira, and we'll want the agent to pick up the data and basically start working through some of the schema changes that we have implemented there. And then we're going to have the race prediction. We already introduced through the ingestion to Snowflake a change to the schema. And we're going to see how through the self-learning process, the agent is able to actually understand what schema changes are, make whatever is required to change within the DBT pipeline, and so like persist that through as we go. So I do have my ticket here created. There's a bunch of information that are required here. So the way how we set up the agent, then I'll walk you through the actual agent setup, is we do have a label that we set within our Jira or Linear. And through our agent template, we'll say, hey, go and see and find what is made agent ready within my Jira board and start working through it. So if I go here now to Bolt, we have already our job set up there. So I'll click on edit so you can see what this looks like in here. So fundamentally, there is two things we do. One is we define what type of agent we want to use for these tasks. And then here we can add additional information to that. So we kept that pretty fair. It's ready deployed. So I'm just going to take a step back and I'm going to press the run button here. So while this starts, I will now switch to the Paradime interface. So our code ID, where we do have our YAML files, which like define the boundaries of the agent, right? So what the agent does, how we want it to behave in certain conditions, and so on, and what kind of settings we've basically set up there. So I'm going to go back here. So, okay, perfect. So the way how the agent works in Paradime is we define them as YAML files that live inside your DBT project or your Git repository rather. And here is where we define a few things. So we can define the roles. So what we want the agent to do. We can define the goal, how we want the agent to iterate through our tickets, what kind of things we want the agent to tackle there. And fundamentally what we do is, final this, we define what kind of tools. So here, for example, we are providing a set of tools related to MongoDB to access the schemas, understand more about the files that we have there and the data. And then we have tools like getting the issue from Jira, listing the issue, and these are more like thinking about work system or like file system tools that the agent can use to work through the task that has been given. And then finally, we have this Slack channel configuration. So think about this is the place where we want the agent to post updates for us, right? So it's the place where we can actually see what the agent is doing. This is configured now, and we can go to the Slack channel here, and we'll see a session, which is the one we just triggered. And so this is where we see the agent working now through the session we just triggered now. So it will post what the Jira informations are, what kind of things it found, what kind of work it's planning to do. Now you see you have a set of tool calls that are happening in the background. So fundamentally now the agent is going through the task, understanding what needs to happen, working through the task itself. So this can take, from a minute or two to a bit longer, depending on the complexity of the task. Now, while this is happening, just something to mention here is that from an agent perspective, the way how we set up the agent is think about as a developer within your workspace. So if I go back to the Paradime UI, well, that's ongoing. I'll show you a little bit. Let me go back. So if you see here, what we do have is a dedicated environment, if you like, for the agent. And here is where we're going to provide the permissions or the credentials to work within Snowflake in this case. This is where we're going to provide this set of information there. And then to utilize the MongoDB and any other integration that we want the agent to actually work with, you do have a dedicated agent integration page. So this is where we define like how to connect to Jira, how to connect to Google Docs, and so on and so forth, like basically how the agent can access third-party systems to fetch and pull additional information there. So whenever we think about whenever we're onboarding an agent, really what we're doing is we are creating what the boundaries of the agent from a YAML perspective are, but also what kind of environment, how the agent will access those environments to complete this task. So if you go back here, it's now walking through the final steps in here, pushing the branches, committing the changes, and finalizing the work. So what we expect now is that on completion, we will be having a PR that fundamentally we can then review and see what's kind of like left from that window on making sure that everything is kind of working as expected, and then PR step. The final thing that we can also define within the agent here is, and something a question that we get very often, like what kind of access we want to give the agent to Snowflake, for example, like how do we want to operate the agent within the Snowflake boundaries. So normally we see things you want to give the agent the ability to create its own, it's sort of like its own schemas and tables, or think about as a kind of like a developer will work through from there. But also you will want to make sure that the agent will have access to read-only mode to your production data. So this is what is going to allow the agent to then like fetch and debug things and check things in the background on that front. So now that the task is complete, this is sort of like the final message that we get, how things were validated, what kind of changes were addressed, what kind of things have passed effectively here. The way how the agent responds in the chat is configurable through that YAML file that we showed earlier. So this is where we can define what kind of information we want in this from the Slack bot, or do we want more or less information, what kind of things we wanted to check, right? So you can select define those things here. And then finally, if I click on view open PR, this is where we get now the final request available. Again, this can sit or can be defined based on the YAML files that we have in place or the definitions that we have there. So all of these things are very customizable in nature, but yeah, it will fundamentally walk through those life cycle from like having the Jira ticket ready to then pick up the ticket and start working through the ticket until we get to a point where some of these issues are resolved in that. So you can see here, there was a checklist and I had in the ticket, it went through the checklist and make sure then accept the criteria were successful and mapping. So again, this is very customizable, but fundamentally we can like define what kind of information we want to be going here. Now, what I'm going to do, I'm going to move to the other use case that we prepared for today, which is failures. So I'm going to go back to my other post caches I have here. So let's go through, actually, so I'm going to go through here. So here we have a DBT job that is running, the simple DBT commands that runs. And you see here, I have definition of what Slack channel the agent should work with when there are failure for self-healing and what's the agent name. So here again, I'm actually using a different agent, right? I'm creating the scope of an agent because we will probably have to do things slightly differently there. And this is the only setup that I have to do at this point. So if I go back and I click on run, what's going to happen is we're going to trigger this DBT job. We expect this job to fail. We know that this is going to fail. And then we can follow inside Slack. As soon as we get the Slack notification, what the agent will effectively work through and do for us there. So while we do that, I'm just switching back to my editor so I can give you a bit of a walkthrough on what the what the agent configuration looks like for this. So a couple of things there. Okay, we're defining what the agent, what's the purpose of this agent in here. How does it work? Okay, what kind of things we expect the paths and the errors, and what kind of behavior we want the agent to do in case of kind of like different versions of data, how we want it to work through it. Again, it's very customizable there. And here again, we will then provide a set of tools which will allow the agent to operate within that task itself. So tools might be similar or different depending on the scenario, but this is the key part where you're going to basically set what the agent can or cannot do. So if I go back now to my Slack channel and I click on this one, so this is the error that we got on the back of that failure. And you see here that there is a self-healing session that started. Okay. Now here we're seeing something interesting, which is it's reviewing the run and it's finding a similar pattern of a previous run. Okay. So what happened is the agent is smart enough to understand that there is a similar error than has happened before related to this. And it will go through the similar workflow now, which was like finding if there is anything that we've done already with this change or this breaking change, working through what will be the best option to resolve it. So what it's referring to is this run that I triggered earlier, where fundamentally this was the very, very first failure that we got to that particular error. So if you see here, what it finds, okay, I found these issues here. It then went and tell me like, hey, this is an issue and something can happen with schema drift happening in MongoDB, what the schema drift looks like, what kind of actions I'm actually taking on the back of it, and then ultimately again getting to the end goal, which is open up PR with descriptions and actions planned later on. Right? So this is the kind of experience we'll get every single time there is a new error a net new error within this workflow. So it's also, again, giving us some information about what to do straight after the PR is merged. You can go and see the PR review and see what is sort of like happening there. Now, the way how we handle this particular scenario is the agent has this concept of memory. So it does have recollection of what are the new errors, what are previous errors. So what we really want to avoid is this scenario where we're trying to fix things several times for this exactly same issue here, right? And you see here exactly what happened, which you basically went and say, hey, I saw this error before. I can see that there is already a PR in place. So what I'm going to do is I'm not going to actually open a new PR. So this is kind of important when you have like higher cadence runs. Let's say something runs every 15 minutes, every 20 minutes. What you want to avoid is to find yourself in a scenario then by the time there is the first error in your pipeline, and by the time your error is completely resolved and merged back, you'll have like several PR open doing exactly the same thing one after the other. So that's the way how the harness sort of like gatekeeping or handling those scenarios. So I can see here's, okay, let me see if there's something already open. Okay, I think I can find the PR, and it basically point me back to that PR that we haven't here. Okay, so okay, this was the error that we got. This was the action of the drift and what happened inside the drift exactly. This is the changes that happened. This is what I've tested in here. And then there's a section of follow-ups and things that the agents like suggesting what to do before merging this PR in that way. So yeah, so those are the like 3 core workflows and we want to tackle during this call. And this is how, again, we can use those agentic experience to save us a bit of time on those tasks where we need to add, remove colors, update schemas at the very source level and use them to streamline some of those processes, but also how the agent can help us reducing as much as possible MTTRs, like how can resolve errors as fast as possible so that we can test them in this kind of scenario. I'll pause here, but yeah, happy to answer any question, happy to dive deeper in a certain area if you like.
So just a scenario, let's say we have a DBT pipeline and you have an agent built on it. Let's say we have 2 scenarios, right? It fails over the weekend and we want to rerun it, one scenario. Second is there is some code change required to it. So can we customize this agent according to the 2 scenarios? Right. And what level of alert we get it, like P1, P2, do we want to fix it during the weekend according to the answer from the agent, or should we wait till Monday to fix it? So can we do it or not?
Yeah, very good question, actually. So let me walk you through the docs here so it can give you a bit of a flavor of how the setup looks like in this kind of scenario. So a couple of things that can help you there is, if I go to the YAML configuration, there are 2 things we can do in your case. One is we can, of course, define what are those conditions, right? What kind of things we want to happen on a weekend, what kind of things, if it's not a weekend, we want to do, what kind of behavior we want. And in this particular example you mentioned right now, what we've seen other customers doing is they create a fleet of agents. So there's like and I'm going to show an example related to Airflow, but we can generalize fundamentally and set up there, which is you have an instance commander, and that instance commander is about defining what agent squad should be invoked based on the condition we set in the YAML file. So here, what we have is this configuration that we support. And then if you look at the tool references, I can do things like run SQL, this and that. And then from an orchestration perspective, you can see I have like explicitly defined commands that can re-trigger runs or re-trigger from point of failure, or start from completely scratch on a DBT pipeline, do a subset of commands. So what is important is that those are pretty powerful tools, and we don't want to give those tools to all the agents. And that's why we have this allow base. We have to be very explicit. What we'll have to do to support or like to define an agent workflow like the one you described is, if you go here and we look at this pipeline commander, we'll basically defining 3 agents, right? Or 4 agents. So there'll be one master agent, and the scope of that agent is actually to figure out what to do. So the error happens. What do we do now with this error? And the agent will think about like a dispatch, right? So basically go and say, hey, if there is this kind of errors, let's call them like a transient error, then your first point of entry will be to delegate to a retrier agent. And that agent will have the boundaries of the agent will not be about opening PR, will not be about making code changes, will not be about running SQL, for example, will purely about what you can do is you can do a run, wait for completing, and then choose whether you want to add some delay. So it might be that you kind of have a sense like, hey, you can retry up to 3 times. At times number 3, report back to the instant commander and say, hey, I've tried, but actually this might be a bigger problem. That might be the second scenario, which you're going to have an agent which does the actual fix. And in this case, the commander will say, hey, in this event or for this type of error, so let's say schema drift and things like that, you do have the ability to go and act on the error right away, creating PR, making changes, but that agent very likely will never have access to retrigger a run. It'll be like, think about independent units in there. They all roll up to the master agent. So the agent is the one that will tell what to do and when. But then those agents, they have very specific scope. That's why we call them agent squad, because it's kind of like in a team, you might have like somebody that is on call on the weekend. You might have somebody which is, focused on fixing certain part of code base. You can think about that kind of mental model.
And we can customize it according to our own needs and use case, whether using it a multi-agent or a simple one.
That's right.
Thanks for the explanation.
All right. Hey, Hamjit.
Yeah. So 2 questions. First is on the Mongo part. So it's only for different databases, and how it records is fine. But once we grow to billion records, whether it will be because it will be doing a schema check, will it be feasible? First thing, and second thing is like how it get the context. So the PR that you raised, that there was a field name change, a double underscore was added, and there was movement of some field to a new collection. But in real life scenarios, how it will get the context, whether the change is desired change, we should add a new column instead of making a coalesce of that, or how do you get the complete context in the real life scenarios?
Yeah, very good question. So what we provide in here, so how it gets the context from MongoDB is through this series of tools that we built. Think about this is some of those are very similar to the MongoDB MCPs, but then we add our own business logic behind it. Okay? So it's not a one-to-one replica. Like the tool calls are very similar, but what we do behind and what kind of boundaries we put behind the scenes are a bit different. So you can think about in the scenario number 1, which is, okay, what if we have several records? How does it go and find things? Well, the agent has the ability to query those records, and it will work through its own internal life cycle to spot based on the error we see, what kind of think about a bit of sampling effectively. It goes, okay, let me check the most recent record, and let me check the records from last week, and let me try and find the difference and spot differences to define what the schema changes are and how to tackle them. So that will be the first one. Related to the second one, what we always suggest is that the agent has what we call a system prompt, which is what we define internally. Okay? And that system prompt is what defines about the high level behavior of how DynaAI is good as data engineering practices. And that's managed by us. For anything else, which is more custom to your own experience, so what kind of things you want or not to do based on different scenarios, you can define those through this YAML file, first of all. But also, if you already have skills, CloudMD, AgentMD, things already in place, then define some of those very specific behavior to your current internal lifecycle. Those are backward compatible to DynaAI, so that there's no need to translate those in a different format, which means in every sessions the agent will do, it will basically inject the skills metadata and work through those. The ultimate things about to solve the second problem you mentioned, like how to decide based on certain condition, it goes back into this memory construct that we built within the agent. So as the agent will get used, it will recollect and store memories about decisions that have been made through our context graph. So it will basically, okay, well, this is how we handle these things in this particular time, and this was a successful handling. So I know that in a way, if there's the next thing happen of a very similar scenario, even if the collection is completely different, this is how I'm going to handle it.
And this can be generic, or this can be at different levels of orchestration we are running. And there can be generic YAML and then specific YAMLs to the different orchestration attached.
That's correct. Yeah. So each job, if you like, in Paradime can have a different YAML attached to it. So from a self-healing perspective, you can say, I have this dbt pipeline that looks up collection of this type of data, and this is what this pipeline does. And for that, I have a dedicated self-healing agent that has certain condition into it. And then I have another pipeline which maybe doesn't use Mongo and has different data, for which is kind of like Mongo behaviors, they're not really relevant. You might get data from Airbyte or something else, a different application, and you might have a slightly different behavior. Right? So a classic thing is that from MongoDB to Snowflake, it's often we're seeing like internal application, internal data being transferred compared with, let's say, using Fivetran for HubSpot, and the level of what you can do in those scenarios is very different.